Hi everyone, in today's lesson we're going to talk about verifying inverses using matrices. But before we can introduce matrices, we have to recall some information from algebra. So the first thing I'd like to discuss is the additive identity. The additive identity for all numbers is 0. What that means is I could add 0 to any number and get back that same number. So for example, if I had the number 4, I could add 0 and I will get 4 no matter what. Or say I had the number -5. I could add -5 to 0 and get 5. Now, the additive inverse is basically you want to ask yourself, what do I need to add to get the identity element, which is 0? So let's use those same numbers. Let's use 4 and -5. What do I have to add to 4? And what do I have to add to -5 to get back that identity element of 0? And you should really just be thinking, I need to add the opposite. So 4 plus -4 equals 0, and -5 plus 5 equals 0. So the definition of the additive identity is just A plus -A equals 0, or -A plus A equals 0. These are the two definitions of the additive inverse. So if I wanted to prove that 2 and -2 are inverses of each other, all I have to prove is that when I add them together, I should get 0. But I have to show both directions. So what do I mean by that? I want to show that 2 plus -2 equals the identity element, and -2 plus 2 equals the identity element. So those two are perfect. That proves that they're inverses of each other. Okay, let's move now to multiplicative identities and inverses. The multiplicative identity for all numbers is 1. So for example, if I take the number 4 and I multiply it by 1, I will get 4. And if I take the number -5 and multiply it by 1, I will get -5. So I could take any number and multiply it by 1, and I'll always get back that same number. So now if we discuss multiplicative inverse, you're basically asking yourself, what do you multiply by to get that identity element of 1? So if we take these same numbers, if we take 4 and -5, what do I have to multiply 4 by? And what do I have to multiply -5 by to get 1? And here is where you should be thinking reciprocals. If I take 4 and multiply it by 1 over 4, I'll get 1. And if I take -5 and multiply it by -1/5, I'll get 1 as well. So the definition for a multiplicative inverse is A times 1 over A equals 1, and 1 over A times A equals 1. This proves multiplicative inverses. So if I want to prove that 2 and 1/2 are inverses of each other, I have to show that this is true. So if I take 2 and multiply it by 1 over 2, I get 1, and 1/2 times 2 gives us 1. So that proves that both of those are inverses of each other. So, how does this relate to matrices? The first thing that we need to start with is defining what the identity matrices are for 2 by 2s and 3 by 3s. So what's the identity element? So for a 2 by 2 matrix, your identity element is 1, 0, 0, 1. Just like that reduced row echelon form, this is the identity matrix. And the identity matrix for a 3 by 3 is 1, 0, 0, 0, 1, 0, 0, 0, 1. So that is your identity matrix for a 3 by 3. So let's do some examples with matrices and see how this works. Let's go to the next page. Okay, so let A and B be two matrices, and let I be the identity matrix. To prove that matrices A and B are inverses of each other, you must show that when you multiply A times B, you get I, and then the reverse way, that B times A gives you I. So, example number 1. Prove that B is the inverse of A where A is this 2 by 2 matrix and B is this 2 by 2 matrix. So to show that B is the inverse of A, you must show that A times B equals the identity matrix and that B times A equals the identity matrix. So my first thing that I'm going to show over here is A times B, and I want to show that that equals I. So my A is -1, -1, 2, 1. Multiply this by 1, 1, -2, -1. Okay? So when we multiply, we're going to take, if you remember, this first row and multiply it by this first column using a dot product. So we're going to take -1 times 1, which is -1, and add it to 2 times 1, which is 2. And then, if I want to find the second column, I'm going to take this first row and multiply it by this column. So -1 times 2, -1 times -2 is 2. -2 times -1 is -2. Okay. Now we're going to do the second row. So now take -1. -1 times 1 is -1. -1 times 1 is 1. And now we'll have this row by this column. So -1 times -2 is 2. And then -1 times -1 is a -1. And now let's add them. So what do we have? -1 plus 2 is 1. -2 plus 2 is 0. -1 plus 1 is 0, and 2 plus -1 is 1. So this is nice. This is my identity matrix. So far, so good. We now have to check the other side. We have to check that B times A equals I. So we're going to take B, which is 1, 1, -2, -1, and we're going to multiply it by A, which is -1, -1, 2, 1, and see what happens. So if we multiply these, we should get the identity matrix. So I'm going to take this row and multiply it by this 2 columns. And then I'm going to do the same thing with this row and these 2 columns. I'd like you to try the same and then hit resume when you're finished. Okay, here's your answer. Alright, so it looks like I did get the identity matrix for both. So we can definitely say that B is the inverse of A. And the proper way to write the answer is that A times B equals I, which equals B times A. So both of them equal the identity matrix. So therefore, A and B are inverses of each other. Okay, so for homework, I would like you to try the next example. I'd like you to prove that this 3 by 3 matrix, A and B, are inverses of each other, or that B is the inverse of A. So to show that B is the inverse of A, you must show that A times B equals I, and that B times A equals I. So take a minute, finish this one for homework, and prove that you get the identity matrices for both of them. Okay, have a good night.